So now what is our topic today? Can you just read it? Differentiation of T cells. What do you mean by differentiation? Maturation. Okay, what does maturation means? Interaction with antigens. Interaction with antigens. Okay, that means these are the maturation is like the combating techniques. Okay, these are like the combating exercises which are being performed by army of the country. Okay, starting where the starting happens, it happens in the bone marrow. Every cell, every blood cell, every immune cell which is roaming around in the blood is produced inside the bone marrow. Okay, so bone marrow is the parent house of all the cells, be it for the T cells, be it for macrophages, be it for neutrophils, monocytes, or B cells, B lymphocytes, or natural killer cells. Any cell which is roaming around, any immune cell which is roaming around in the blood, which is moving around in the blood, is being produced inside the bone marrow. Okay, after the production, these T cell precursors come towards their educating school, that is their nursing school. Okay, where they are being nursed, where they are being nurtured, where they are being matured, and they make two varieties. One of them is CD4 variety, one of them is CD8 variety. Actually these two precursor cells remain same, but they express different kind of T cells on their surface. For example, this was one kind of T cell surface, and this is another kind of T cell surface. Okay, and the scientists or researchers named them according to their differentiation or cluster of differentiation, that is called as CD. CD is the cluster of differentiation. This is the receptor that is present on the surface of the T cells. Moving ahead, there is one cell is CD4 plus cell, other is cell is CD8 plus cell. The function of CD8 plus cell is very clear and very vague. Okay, it is very apparently clear that CD8 plus cells are just there to perform their cytotoxic activity. That means they know nothing. They are the encounter specialist. Okay, do you know the encounter specialist, police? That means they have to kill the terrorist. Encounter specialist. Okay, they just know how to kill the infected cell. They don't know the process how to proceed the inflammation or what to do. They just have the guns, they just have the bullets, which are the perforins and grain enzymes. They put these bullets inside the pathogenic cell so that the pathogenic cell could be killed. Okay, further moving on, we have got CD4 plus cells. These CD4 plus cells are actually the purpose of helping the citizens. Okay, so these are named as helper T cells or TH cells, and these cells get mature into different varieties after going into the lymph node. Okay, after going into the lymph node, there they get converted into T helper 1 cell, T helper 2 cell, T helper 17 cell, T regulatory cell. Let me tell you one more thing, that these T cells themselves release, or macrophages release, these kind of cytokines. Okay, these all are cytokines. There could be in the form of interferon gamma, which is released by macrophages, interleukin 12, which is released by itself T cell. Okay, that is called as autocrine stimulation. Okay, so interferon gamma and interleukin 12 are the two cells which stimulate these helper T cells to get converted, to get matured into the T helper 1 cell. Moving on, interleukin 2 and interleukin 4 also stimulate these helper cell to get converted into TH2 cell. TGF beta, that is called as transforming growth factor beta, and interleukin 1, interleukin 6, all are responsible to convert these preliminary helper cells, these rudimentary, these starting helper cells, into T helper 17 cells. Moving on, transforming growth factor beta and interleukin 12 both are responsible to convert these helper cells into the T regulatory cells. The word regulatory itself is showing that these cells would perform the regulation in case of immune system. Okay, regulation in case of inflammation. So we discussed about the positive effects. Now we have got the braking system in the car. or stopping system in the car, so that we can manage in production and stoppage of the production in case of this factory, that is lymph node. Okay, you need both things, accelerator and the braking system, to operate a car or to operate a vehicle. Same goes for this differentiation of T cells. Interleukin 4 and interleukin 12, let me tell you one thing, always remember that interleukin 12 is anti-inflammatory. Okay, is anti-inflammatory. This is anti-inflammatory. That means it will stop the conversion of these inflammatory cells, because these cells will ultimately cause inflammation, the CD4 plus cells or CD8 plus cells. Okay, so the conversion of helper cells into the Th1 cells is stopped by this interleukin 12 and also interleukin 4. Okay, can you just observe here that this interleukin 4 stops the conversion of T helper into the Th1, but it stimulates the conversion of T helper into the Th2 cells. Okay, so it just goes vice versa. And you can observe another thing, that this interferon gamma here is stimulating the conversion of T helper cells into Th1 cells, but this same interferon gamma is also stopping the conversion of helper cells into the Th2 cells. So this interferon gamma stimulating these cells to convert into, or you can simply say interferon gamma helps formation of Th1 cells, and interferon gamma stops the formation of Th2 cells. Okay, and or you can say that interleukin 4 is responsible for the stoppage of Th1 cells and promotion of Th2 cells. Okay, just have an idea that there are some interleukins that work vice versa. Okay, so moving on, this interferon gamma also also gives a negative effect on Th17. Same goes for interleukin 4. Interleukin 6 gives a negative impact on the on the formation of T regulatory cells. These 4 cells then ultimately come towards the blood. First of all, they were produced in bone marrow. They went to their educating center, which was thymus. After that, they came for secondary education, which was available in the secondary lymphoid organ, which was lymph node. And after that, they will come into the society to serve the society. Okay, they will perform their jobs. So what is the job of Th1 cell? The job is to secrete interferon gamma and interleukin 2. Okay, these two will again cause the conversion of T helper cells into Th1. So these are performing in a cycle. Okay, these same two will also perform here. So, and these two are also responsible for activating the macrophages and cytotoxic T cells, which were CD8 plus cells. Okay, they will also activate these cells and they will also activate macrophages. Okay, in biology, in medicine, these things are so complex. Nature has created a human so complex that you can't even understand properly or completely a single function of a single cytokine. But you can have an estimate for the treatment purposes, that what is the purpose of these inflammatory cytokines. Okay, Th1 secretes interferon gamma and IL-2 to activate macrophages and cytotoxic T cells. Th2 secretes interleukin 4, interleukin 5, interleukin 6, interleukin 10 and interleukin 13. So we in a session, if you remember that in a previous session, one of the previous sessions, we discussed that interleukin 5 is responsible for chemotaxis, and it is also responsible to activate these eosinophils. Okay, while the interleukin 4 is responsible for the production or stimulation of IgE. We will also discuss these interleukins in the next topic, because I have sent you in the WhatsApp chat that we will cover these topics. Okay, just keep an idea that interleukin 4, 5, 6, 10 and 13 secreted by Th2 cells activate the eosinophils and increase the IgE circulating levels. Okay, moving on, we have got T helper cell 17. Okay, T helper 17. they secrete, because the name is 17, they secrete interleukin 17, interleukin 21 and interleukin 22. What is the purpose of these interleukins? Is to induce neutrophilic infiltration. Keep that thing in mind. Okay, what we mean by infiltration? That means the neutrophilic accumulation or neutrophilic chemotaxis in the areas where inflammation is lying, the interstitial areas. Okay, moving ahead, we can just observe here that T regulatory cells secrete interferon TGF beta, transforming growth factor beta, interleukin 10 and IL-35. Let me tell you one more thing, that the word regulation, what do you mean by regulation? What do regulatory authorities do? Can you tell me? In our society, what is the purpose of having regulatory societies? First of all, the building is working, that building will have the regulatory authority or regulatory people which usually perform the regulation of that area. Just tell me, what is the purpose of having regulatory authority? To make sure that everything is working properly. That means these regulatory cells will also perform functions so that everything could work properly, so that it could prevent autoimmunity. That's why these cells secrete these anti-inflammatory cytokines. Okay, that's why they secrete anti-inflammatory cytokines, so that they can keep up regulation on the immune system. And those anti-inflammatory cytokines, the most significant ones are TGF beta, transforming growth factor beta, and interleukin 12. Okay, they prevent autoimmunity and maintain tolerance. What do you mean by tolerance? Can you tell me? Yes, what do you no, actually tolerance means not giving a reaction. Okay, for suppose you are tolerating a family member, for suppose my sibling, my sister, a lot of times she stimulates me for something. Okay, she teases me for something, but what I tolerate her or she tolerates me. What does that means? We don't give reaction to each other. Okay, not giving reaction. That means our immune system will not give extra reaction to self antigens, so that, because these T cells and B cells, these are not human beings, they don't know which cell is self and which cell is foreign, which cell is foreign. Okay, so to prevent that thing, nature has created these two cytokines, so that our immune cells can maintain tolerance to our self antigens, not giving reaction to self antigens. Okay, that is called as tolerance, and this tolerance helps to keep up for preventing the autoimmunity. What is autoimmunity? Autoimmunity is reaction of our own immune system against our own cells. Okay, these, you can just keep this thing in mind, that these regulatory authorities are there to prevent corruption in the police department. Okay, and that police department is autoimmune system. Moving ahead, I hope you got this differentiation of T cells. Okay, okay, anything you want to ask me, because these things are to be crammed, these things are to be remembered. Okay, you have to keep this thing in mind, that interleukin 12 and interferon gamma and IL-2 is released from Th1, activates macrophages and cytotoxic T cells. There is no concept actually. The concept which I am gonna discuss now, just have a concentration on that. I told you that T cells and B cells, especially T cells, these T cells sense different kind of antigens. Okay, with the help of T cell receptors. With the help of, can you repeat me? T cell receptors. Okay, T cell receptors. Repeating keeps you awake actually. Okay, repeating keeps you focused. Yes. Moving ahead, these T cells have got T cell receptors, so that they can sensitize the foreign antigens. But these T cells are not human beings, bro. These T cells are just simple, a tiny bit T cells. They don't have sense. So how will we treat them? How will we educate them so that they can just kill out, or they can just sense out the only foreign particles? Okay, for example, this is a self antigen. For T cell, these two boxes are approximately same, but this is foreign, this is a foreign bacteria, and this is a self cell of the body. Okay, this is a self cell of body, but T cells don't know that which is the self cell and which is the foreign cell. For that purpose, nature has created a mechanism that is called as positive selection and negative selection. That is called as, can you tell me, that is called as positive and negative selection. The word positive selection itself means that we will let the T cells survive. Okay, some kind of T cells we will let them to survive. And negative selection means there is some sort of T cells we will kill them out. We will cause their apoptosis. Okay, so this positive selection happens inside of the cortex. Okay, happens inside of the cortex, the positive selection. And in case of medulla, which is the middle region of the thymus, there is a selection named as negative selection. Okay, what happens with the positive selection? All those T cells, either it could be especially these CD4 plus cells. Okay, because CD8 plus, let it be CD8 plus also. Okay, these both kind of T cells, CD8 and CD4. Okay, all those T cells that can sense foreign bodies with the help of MHC molecules, with the help of self MHC molecules. Okay, they can, all those cells which can bind to the self MHC molecules, that means they will also bind the foreign antigens. That's why we let them to grow. Okay, that's why we let them to survive. That's why our body promotes their development. We can just end. What is the negative? So we are clear with the positive selection, that all those cells which can bind to the self MHC molecules, we will let them to survive. Okay, this is self MHC molecule. That means they can also bind to they have affinity to bind the foreign antigen. This was the foreign antigen here. I took it here for the understanding purposes. Okay, and this is MHC molecule. Moving ahead, what is negative selection? What is negative selection? In case of negative selection, what we check out to our CD4 or CD8 plus cells, we check out that if these cells could bind to the cells of the human body, could bind to the cells of the human body. For suppose these are the cells. Okay, these are CD4 cells, they have got T cell receptors. CD8 plus cells, they have got T cell receptors. Okay, this T cell receptor, this is T cell receptor. So this was a foreign particle, but I also told you that first of all this is a self antigen, self body cell. What our body will do, there is a complex of genes called air genes inside the thymus. They make antigens similar to self cells of the body. Okay, what is the complex? Can you tell me what is the gene complex? Air gene complex, AIRE gene complex. And this full form of air gene is autoimmune regulator genes. They are used to make, they are present there to make antigens or antigenic components. For suppose this is the antigenic component, they made this antigenic component just as similar as to the cell body. Okay, body cells. Okay, they make antigens similar to the cells of the body. So what these antigens will do here in the medulla region, they will come towards the CD8 plus cells and CD4 plus cells. If these cells are able to bind them with higher affinity, that means these cells are harmful, because after releasing to the blood, what they will do, they will bind to our body cells and they will destroy our normal body cells. That's why our body is, nature made our body to kill them, to kill these cells which have higher affinity to bind the self antigens. Okay, You got me? For suppose the CD8 cell is highly capable to bind the self antigen. That means these two cells are very harmful for the body. That's why we have to kill them out. Okay, that is called as negative selection. That happens inside the medulla, and the positive selection was all those cells which are capable of binding the MHC molecules, that means they can bind to the foreign body which we have to kill. They can kill out the foreign body. That's why we have to let them grow and kill out these cells which are binding to the self cells. That is called as positive selection and negative selection respectively. I hope you got me. Okay, moving ahead, I want you to read this. Okay, go on and read this. Positive selection and negative selection. Yes. What does it? Explain? Just explain me. You are my teacher now. Give me a little bit of explanation. What does thymocortex mean here? No. This is not brain. This is the cortex of thymus. Cortex could be of any organ. Cortex is a Latin word for outer area. Okay, cortex is a terminology for outer area, medulla. Yes. Thymic cortex is inside the thymus. Thymus is the gland which is present just in your neck. Okay, just in front, just above your chest area and just below your neck area. Okay, it is present just here. So that is the cortex of thymus. Go on and read it. What are TCR? T cell receptors. Okay, so you got it, that when, yes, I am repeating it, no problem. Okay, I am repeating. In the cortex of thymus, I just told you to read this because you have just got awake right now from the sleep. Okay, I know that, so you will have the concentration on it. See, this is the cortex. Cortex is the outer region of thymus. This positive selection occurs in this region. Double positive is just to memorize. Okay, this is kind of mnemonic. That means CD4 plus and CD8 plus cells. Okay, these CD4 plus and CD8 plus T cells express T cell receptors. Can you see my cursor? Okay, this is here. Okay, these are the, for suppose, T cell receptors. These T cells express T cell receptors, and they are if they are capable of binding self MHC. If they are capable of binding self MHC. What do we mean by self MHC? Those MHC molecules which are present on the surface of cortex, which are present on the cortical epithelial cells. Okay, in this cortex we have got epithelial cells, and on those cells we have got MHC molecules. If these T cells are able to bind the MHC molecules, then we have to let them grow, and that is called as positive selection. And why we are checking this? Why we are checking this MHC binding? Because this MHC is also present on your antigen presenting cells. Okay, just let me change the pen. Okay, also present on APC. What are APCs? Can you tell me? Macrophages, dendritic cells, B cells. Okay, these are the antigen presenting cells. Macrophages, dendritic cell and B cells. All these cells have got MHC molecule on their surface, and that is called as MHC1 or MHC2 receptors. Okay, MHC1 receptors are present on all the nucleated cells except red blood cells, because red blood cells don't have nucleus. Okay, or they actually have nucleus. I don't actually remember, but just keep this thing in mind. I am sure about this, that MHC1 molecule, MHC molecule 1 is present on all the cells of all the body cells except the RBCs. Okay, and these MHC2 molecules and the MHC2 molecules are present on the antigen presenting cells, especially macrophages, dendritic cells, and B lymphocytes. Okay, so these MHC molecules will present an antigen to the T cells. Okay, ultimately what these antigen presenting cells will do, they will present an antigen to the T cells in the peripheral blood. Okay, so if those T cells, if these T cells are able to bind to this MHC molecule, they will be selected in your thymic cortex, because this is the educating center. Okay, in this center T cells get education to bind to the self MHC molecules. If they can bind to the self MHC molecule, they will be let grown. Okay, they will be promoted to grow, they will be promoted to develop. If they cannot bind this self MHC molecule, they will be killed out. Okay, and so you got the positive selection purpose. Can you tell me what is the purpose of positive selection? Yes. Okay, select those. Yes. Yes, and the purpose of positive selection, let me just open one more thing. Let me do it on the chat GPT. Okay, so let me write what is the purpose of positive selection in thymus. Okay, go on and read these 4 lines. Okay, so these 4 lines are just giving you the whole concept of positive selection. What is positive selection? It happens in the thymus, ensures that developing T cells with functional antigen receptors that are called as T cell receptors are capable of recognizing self peptides presented by MHC molecules survive and mature. Okay, because in future these T cells will go into the peripheral blood and they have to pick the bacteria for the killing purpose, so that they may not kill the self cells. Okay, because if this process is not occurring, what will happen? Your own immune cells will eat up your body cells. Okay, and that is very dangerous for your body. That's why we have to educate them. These are actually stray dogs. Okay, you have to educate them that you don't have to bite the citizens, you just have to bite to the thief, or you have to bite to the terrorist, or you have to bite the culprits. Okay, these are the stray dogs. Actually, you have to educate them in the thymus. These T cells are just like the stray dogs, and you have to tell them, you have to teach them that these are self peptides you don't have to eat them. If they don't pass this exam, what we will do, they will be eliminated. Okay, they will be eliminated to prevent the autoimmunity. I'm just gonna copy this and put this in our first aid. I will send you later. Okay, just have an idea that what is the purpose of positive selection. The purpose of positive selection is to prevent the autoimmunity. Okay, I hope you got it. Because in first aid we can just see the headings. Okay, these are just headings. In real, the positive selection is a very big topic. Can you just see here? Okay, this is the whole topic. I just asked this ChatGPT to give the brief response. Okay, but all these things are also important. If you have got time, just go on ChatGPT, write that what is the purpose of positive selection, what is the purpose of negative selection in the thymus, what is T cell differentiation, and you will find so many things which we have to study actually. But right now we have to focus on the important things which are present here in the first aid. Keep one thing in mind: purpose of positive selection is to select those T cells which are capable of binding self-MHC molecules. Okay, on the cortical epithelial cells will survive. If they cannot bind to the self antigens, that means they will be killed. Okay, moving ahead, we have got this negative selection. The word positive selection means letting survive. Okay, letting someone to survive. Negative selection means we have to kill those cells which are binding to the self antigens with high affinity. Okay, just go on and read these lines. Go on and read from here. Can you just give me the idea that what this line is telling you? Just tell me whatever you are getting from that. Go on. Yes. That means they are capable of harming your self body cells. Okay, that means they are capable of harming your self normal functioning body cells. To stop that, we have to kill these cells. We have to what we say, court martial. Okay, army people are these corrupt army persons are court martialed. Okay, that means they are suspended from their job. We are right now suspending these nasty T cells which are actually capable of binding to their normal functioning body cells. We don't want to destroy our normal functioning body cells actually. Okay, and what we will do, either we will let them to get apoptosis. Okay, do you know what is apoptosis? Self killing of the cell. Okay, this is a suicide of a cell, actually, kind of suicide. We are actually killing them with a chemical messenger in a decent way. We are just burying them by making their funeral. Okay, so either we will let them apoptosed, okay, or we will try to make regulatory T cells from them. So we are just educating these nasty cells to become responsible citizens, and we are recruiting them into our regulatory authority. Okay, we are making them T regulatory cells so that they could secrete TGF beta and interleukin 12, interleukin 35, so that they could prevent autoimmunity and maintain the tolerance. What is tolerance? Not giving reaction against the self antigens. Not giving reaction against self antigen. Actually, these dots are connected to one another. In the first few minutes, I told you what is the purpose of, what is the meaning of tolerance. This whole process this whole process, this whole differentiation of T cells, this education of T cells is actually required so that they can behave normally. Okay, what a child learn in a school, okay, what a child learning in a college, they learn discipline. Okay, education is not just reading the books, it's learning the discipline, that how to be a responsible citizen when we are moving to our future. Okay, and that thing happens to the T cells. Let me tell you one more thing. I told you that we are just seeing here that these T cells are able to bind to the self antigens, but these self antigens are secreted, are produced with the help of a regulator, with the help of a regulator with complex of regulator genes, and those are called as autoimmune regulator. Those are called as autoimmune regulator. Can you tell me what is the purpose of this autoimmune regulator genes? To make self antigens to make self antigens to be. Actually, you can just keep this thing in mind, that these autoimmune regulator genes are preparing exam for the T cells, and that exam is in the form of self antigens. In the thymus, in this organ, this air complex is responsible to make self antigens. Can you just read this? Go on and read this. Tissue restricted. Okay. Did you get this? Can you tell me what is the purpose of air complex? Yes. See what is happening in your thymus. These T cells are present there with the surface receptor on them, that is called as T cell receptor. Okay, these cells are actually here. These T cells have came from bone marrow. These T cells have came from bone marrow to the thymus for education with the T cell receptor on them. Now what will happen in the thymus? Their maturation will occur, that means interaction with the antigens will occur, and these self antigens will be formed with the help of this complex. Okay, they are just here to give an exam, and that exam is being prepared by an examining authority, that is the testing service. That testing service is autoimmune regulator. Okay, you get me? Yes, for interaction to the T cells, with the T cells. Okay, so for suppose this autoimmune regulator or testing service is corrupt, or this testing service is not working properly, what will happen? We will not be able to make these self antigens. Am I clear? For suppose this regulatory authority is not working properly, what will happen? We will not be able to prepare the self antigens. Our T cells will not be able to interact with the self antigens. They will not know that what is self and what is foreign. Okay, let me tell you one more thing, one more example. For suppose I am in my home. For suppose I am a married person. I know how to behave with my sister and how to behave with my wife. Okay, and that is the actual education, how to behave with my mother and how to behave with my daughter. Okay, I know how to behave with my father and how to behave with my same age brother. Okay, I can take the name of my same age brother, but I can't take name of my father. Actually, I used to call him Papa or anything, Dad. Okay, so what is that thing? That is education. That is a kind of behavioral thinking that was told to me within my house. That means in bone marrow. That was educated to me in our education system. That was thymus. In our society, that was lymph node and peripheral blood. And that thing, for suppose there is a person who is living in forest, okay, who has not seen humans for the time, he will not be able to differentiate between the siblings and the wife. Okay, he is like an unaware, uneducated person. And these T cells who have never seen the self antigens, they will also behave very dangerous. They are dangerous for society. What they will do, they will do nasty things with our self antigens. Okay, they will actually I don't want to use the word, they will actually fuck up the things, fuck up the whole situation. Okay, they will actually damage the self antigens, they will damage your self organs, they will destroy you from start to the end. That's why we will see deficiency of AR genes leads to autoimmune polyendocrine syndrome 1. Autoimmune, poly means so many, endocrine means your glandular organs, syndrome means there are so many diseases. Among those, one of them we will see is chronic mucocutaneous candidiasis. That means we will face candida infection again and again in our mucus and skin. We will see hypoparathyroidism, that means our parathyroid will be diseased. We will see adrenal insufficiency. Adrenal is a gland that is present just above your kidney, and we will see recurrent candida infection again and again. You can just keep a mnemonic in your mind. Without air, your body will char. What does char means? Can you tell me what is the meaning of char? Destroyed. Okay, your body will get destroyed. Without air, you will chair. Okay, air means AIR. Air is so much important for respiratory purposes, for your living. Okay, so keep this thing in mind. I am focusing on this, I am just spending time on this because I have seen an MCQ in UWorld on this. That's why I am giving these examples again and again, just to keep a focus on this, because in first aid I know everything is important, but those things which are present in the UWorld questions, those are super high yield. Okay, these 2 hours are for those things actually, because you can just go to the chat GPT and read the things, but how you can focus on the question is by seeing that what is important in first aid. Okay, so I hope you got the concept of negative selection, what is negative selection? Expressing T cell receptors on the T cells will get, if they are binding to the self antigen, that means they are fucking up their self siblings, or they are fucking up their self organs. That means they are destroying their self organs. Okay, so what we will do, we will kill those cells. For suppose these self antigens are not being formed, these cells will not be able to recognize these antigens. Okay, they will not be able to get the education. So what they will do, they will destroy your own organs, and among those organs you have the parathyroid organ and the adrenal organ, and you will see the recurrent candida infections. Okay, all right, should we move on to the next? Okay, let's move on to the next. First of all, these T cells got matured. Okay, now these T cells will come inside the blood. Here inside the blood, just read this line. I have already told you, immune tolerance refers to the state in which immune system does not respond to specific antigens, including body's own tissues and cells. Okay, so now what these T cells will do, these T cells will come in the blood after getting the education. They have got their surface receptors. They will actually interact with the macrophages, because macrophages are antigen presenting cells. Macrophages have got MHC on their surface. After seeing a bacteria, macrophages will pick this bacteria inside their cells. They will destroy this bacteria and make components of this bacteria, so that these antigenic components, pathogenic components could be presented on the MHC and could be sensed by your T cells. Okay, so for suppose this bacteria is Mycobacterium tuberculosis. What these bacteria will do, they will stimulate these macrophages to secrete a substance. That substance is called as interleukin 12. This is a cytokine. This interleukin 12 stimulate these T cells, and in response these T cells will secrete a substance that is called as interferon. Can you tell me interferon gamma? Okay, interferon gamma. And what interferon gamma will do, it will stimulate this macrophage again and again, and this is a cycle. Macrophages will stimulate T cells, T cell will stimulate macrophage, macrophage will stimulate T cells, T cell will stimulate macrophage to get activated and to perform further better. Now go on and read this macrophage lymphocyte interaction. This is T lymphocyte. Okay, go on and read this from here. So I told you about the end. Okay. Are you asking something? Okay. So I told you about antigen presentation already, that these macrophages will pick up the bacteria, they will kill this bacteria, they will destroy this bacteria into components, and one of the component will be presented on the MHC class 2. This MHC class 2 will be presented to the T cell receptor. Okay. Let me tell you now one more thing. There is the nature or God. Are you a believer? Okay, so let me tell you one thing, that what nature or what God has done. So let me tell you one thing, what nature has did, that nature has created so many signals so that our immune cells could perform very specifically, because these immune cells, because the police or army which is present for your protection, they also can destroy their own country with their weapons, and there are so many cases we have seen. Okay, there was a revolution in Turkey, there was a revolution in France, and all those revolutions were against martial law. Okay, or against their own army, because their army was ruling them. Actually, and army isn't there to rule them, army is there to just protect them, and same goes for your immune cells. So what will happen, what nature has did, nature has also put some other ligands and receptors. This is CD40 ligand, and this is CD40 receptor. After the antigen presentation, what will happen, these two will also interact with one another. Okay, the CD40 receptor will interact with CD40L. That bro, I am giving you the confirmation that now get activated and release some cytokines and try to promote the inflammation so that we can kill out the bacteria, and that bacteria was especially present here. And this T cell will also call upon the B cells with the help of these tiny cytokines. Okay, these tiny cytokines will go to the B cells and will ask B cell to secrete little bit antibodies, and those antibodies will also are also important to kill these bacteria which are present or roaming around in your blood. First of all, this is bacteria. These antibodies will come here and they will attach to them. They will again call upon complement, and after the complement, because complement is garnishing them, okay, complement is opsonizing them. After that, many macrophages will get activated and they will try to destroy each and every bacteria present in your body. This is the whole mechanism which I have simplified for you, but this is actually, in reality, this is very complex. This is beyond understanding. Actually, you cannot understand God's plan, okay, but you can have an idea that how inflammation is being performed, okay, by these immune cells. And one of the important aspect was how macrophage is interacting to the lymphocyte. Macrophage is interacting to the lymphocyte in the form of antigen presentation, in the form of interferon gamma, in the form of CD40 ligand. Okay, this same receptor is also present on the B cells here. Okay, this CD40 ligand is also, another CD40 ligand is also present here, and this CD40 receptor which was present on the macrophages, because macrophages are antigen presenting cells, B cells are also antigen presenting cells, they also contain this CD40 receptor. Whenever these two get interacted, okay, whenever, for example, this T cell is interacting with your B cell. This CD40 and CD40 binding will cause class switching. What is class switching? What is class switching? Can you tell me what is class switching? Class switching is formation of AGE. That means immunoglobulin A, immunoglobulin G, immunoglobulin E from immunoglobulin M. Class switching is formation of. Do you remember I told you B cells have to mature with their age? That means B cells get mature, they make plasma cells, and those plasma cells are actually responsible to secrete immunoglobulin A, immunoglobulin G, immunoglobulin E from the parent immunoglobulin M, and that is called as class switching. Okay, that means one class of antibodies is being switched to other classes with the help of CD40 L and CD40 receptor interaction. It is confusing, a little bit confusing, because it also happens in case of macrophage lymphocyte interaction and B lymphocyte T lymphocyte interaction. Okay, just have an idea about that. You don't have to remember each and everything, just have a concept of this thing, that these things are also happening in your immune system. And I want to tell you that I have seen a question on this also, and on this class switching, that this class switching occurs. Yes, class switching occurs with the help of CD40 and CD40L ligand. Okay, CD40 ligand and CD40 receptor that is present on the B cells. Okay, I have seen a question in UWorld. I will show you after this session or at any time, but just keep this thing in mind, that there is a question on this whole scenario. I hope you got it, the macrophage lymphocyte interaction. Moving on to the next, we discussed the whole story, the whole movie, the whole chapter about the CD4 cells going into the helper cells, TH1, TH2, TH17, T regulation, and their functions also inside the peripheral blood. But now we have discussed about the CD8 plus cells. Okay, CD8 plus cells, after maturation into the thymus, they get mature into the cytotoxic cells in the lymph node, and after that they come towards the peripheral blood and they perform their function. What is their function? To kill the virus infected cell, neoplastic cells, and donor graft cells by inducing apoptosis. Okay, what is the purpose of these cytotoxic cells? To kill the virus infected cells, because whenever your body cell is infected with virus, this virus is intracellular organism. Okay, this virus depends on the host machinery. This virus is always eating the nutrition from your own body cell. Your cytokines, which are released by this T cell, your antibodies, which are released by B cell, your interleukins, which are released by macrophages, are not able at any cost to enter into this cell. They cannot kill this cell, they cannot go inside this cell. That's why God Almighty, the God, the nature, has created something that is responsible to kill these virally infected cells. Okay, and that thing is cytotoxic cells. What will happen in these viral cells? These viral proteins will go into the nucleus and they will get replicated. Okay, they will get replicated. The genes of this virus will get replicated inside the cell, and one of the gene, for suppose, came to the surface with the help of MHC1, because MHC1 is present on your all body cells except RBCs. Okay, am I clear to you? This viral protein has just now came to the surface with the help of MHC. They will call upon the CD8 plus cells, or CD8 plus cells will, whenever CD8 plus cells recognize them, what they will do, they will secrete some important things. Okay, they will secrete some important things, and those things are called as, can you name them? What those things are called as? Gray enzymes and perforins. Gray enzymes and perforins, and these are bullets to kill virally infected cells, neoplastic cells, and donor graft cell, because donor graft cell is also a foreign body for your immune cells. Okay, so you got me. And what is the purpose of cytotoxic T cells? The virally infected cells, because virally infected cells cannot be killed with the help of B cells, that means with the help of antibodies. Antibodies cannot go inside the cells, cannot be killed with the cytokines which are released by T helper cells, cannot be killed by the macrophages, cannot be killed by the neutrophils, cannot be killed by the eosinophils, cannot be killed by the basophils. So whole of the immune system is not able to kill your virally infected cell. There is a one special cop, that is cytotoxic T cells. Now go on and tell me what is written here, and you are my teacher for next 2 minutes. Go on and explain this from here. Yes. To kill the viral infected cell. Yes, these perforins and granzymes will create a hole here. Okay, after the hole, the cell will get all the fluid from the extracellular fluid will get inside the cell. The cell will get swollen. Every mechanism inside the cell will get halted. That means virally infected cell will get apoptosed ultimately. Okay, let me tell you one more thing now, that nature has given MHC1 to each and every cell, just because that if any body cell get damaged, that could be killed easily with the help of CD8 plus cells. So nature has created a specific MHC for the specific COP. Okay, this is a specific signal created by the nature, created by the body, so that they can easily kill the infected cells. Okay, because MHC2 will be presented on the antigen presenting cells containing the components of bacteria, parasites, pollens, dust, drugs, anything, any foreign antigen, all other foreign antigens will be presented on the surface of MHC2. But for virus, because virus is a nasty thing, that's why nature has created a combating technique to the viral infections. Okay, go on and read the last line. Are you there? Hello.